Hello. Tonight, we're going to explore 100 obscure, curious, and quietly bizarre facts about space. I'll count them softly as we go, not like a rapid-fire list, but like we're turning the pages of the old book together, pausing to appreciate each strange new discovery. The goal here isn't to learn or memorize. It's to give your mind a long, meandering path to walk down, a path filled with gentle wonder and fascinating little details. It's a quiet tour through the strange footnotes and bizarre trivia of our cosmos, designed to occupy your thoughts just enough to let sleep find you peacefully. So, let's turn to the first page. Our first curiosity, fact number 1, takes us to the smallest and innermost planet, Mercury. We often think of planets as being static, unchanging spheres, but Mercury is actively shrinking. The planet has a massive iron core which has been slowly cooling and contracting over billions of years. As this giant core shrinks, it causes the planet's rocky crust to buckle and wrinkle like the skin of a drying apple. This process has created enormous cliffs or scarps that crisscross the planet's surface, some of them over a mile high. Mercury is a dynamic, geologically active world, quietly getting a little smaller every single day.
Now for fact number 2. Let's drift over to the next planet, Venus. This world is a hellscape with surface temperatures hot enough to melt lead. But high up on its tallest mountains, scientists have detected something bizarre. There appears to be a kind of metallic frost or snow. It's far too hot for water ice, of course. Instead, radar data suggests that at the cooler, high altitudes of the Venusian mountains, heavy metals that have been vaporized in the hot lowlands, like lead sulfide and bismuth sulfide, can condense and fall as a thin, glittering layer of metallic snow. It's a beautiful and deeply alien kind of weather. Our third strange truth, fact number 3, brings us back to our own cosmic backyard. We all know Earth has one moon, but did you know we have a second moon of sorts? It's an asteroid named 3753 Cruithne, and it's what's known as a quasi-satellite. It doesn't orbit the Earth in the traditional sense. Instead, it has its own separate orbit around the Sun that is so similar to Earth's that it stays in a strange, synchronized dance with our planet. Its looping, horseshoe-shaped path means that from our perspective, it seems to be in a slow, awkward orbit around us. It takes nearly 800 years to complete one of these bizarre loops. It's our quiet, little-known, and very distant companion. And for fact number 4, another one about home. If you were asked to name the highest point on Earth, you'd almost certainly say Mount Everest. And you'd be right if you're measuring from sea level. But because the Earth is not a perfect sphere, it bulges at the equator due to its rotation. The highest point when measured from the absolute center of the Earth is actually the peak of Mount Chimborazo in Ecuador. Because it sits right on that equatorial bulge, its summit is the farthest point from the Earth's core, making it, in a way, the place on our planet that is closest to the stars.
Let's now begin our tour of the truly bizarre moons of our solar system. For fact number 5, we travel to Saturn and its strange moon, Iapetus. Iapetus is a world of perfect contrast, sometimes called the yin-yang moon. One entire hemisphere of the moon is bright and reflective like fresh snow. The other hemisphere is as dark as charcoal. This two-toned nature is one of the solar system's great mysteries. The leading theory is that the moon's leading hemisphere, the side that faces forward in its orbit, has been slowly sweeping up dark reddish dust from another of Saturn's irregular moons, Phoebe. This dark dust absorbs more sunlight, causing the ice beneath it to sublimate away, leaving an even darker concentrated residue behind. The other side remains pristine and white. It is a world perpetually half in shadow, half in light. For fact number 7, let's stay with Saturn for a moment and visit some of its tiniest moons. Saturn has several small moons that orbit right within its famous rings. 2 of them, Pan and Atlas, have a truly bizarre shape. Over eons, they have swept up loose, icy particles from the rings, which have accumulated around their equators. This has created a prominent equatorial ridge on each moon. The result is that they look less like moons and more like cosmic ravioli, or perhaps a classic flying saucer. They are tiny, sculpted worlds shaped by the very rings they help to maintain. Now for fact number 7, we journey out to the distant blue planet Neptune and its largest moon, Triton. The surface of Triton is one of the strangest we've ever seen. A large part of it is covered in what planetary scientists have nicknamed cantaloupe terrain. It looks exactly like the textured skin of a cantaloupe melon, a landscape of dimples, bumps, and ridges. No one is entirely sure what causes this unique pattern, but it's thought to be the result of a complex history of icy volcanism and tectonic activity, constantly reshaping the moon's frozen nitrogen surface. And for our 8th curiosity, fact number 8, we stay with Triton. As we mentioned in another story, Triton has a retrograde orbit, meaning it orbits Neptune backwards, against the direction of the planet's spin. This is a dead giveaway that Triton is not a native moon that formed with Neptune. It is a captured object, a dwarf planet from the Kuiper Belt, much like Pluto, that wandered too close to Neptune billions of years ago and was caught by its immense gravity. This violent capture event likely destroyed Neptune's original moon system and left Triton in its strange, backward path. Let's head back inwards now to Mars for fact number 9. Mars has 2 tiny potato-shaped moons, Phobos and Deimos. Phobos, the larger of the 2, is in a very slow death spiral. It orbits Mars so closely that the planet's gravity is constantly tugging on it, causing its orbit to decay. In about 50 million years, Phobos will either crash into the surface of Mars, or, more likely, it will be torn apart by tidal forces, its rocky body shattering to form a small temporary ring around the red planet. And for our 10th curiosity, fact number 10, a strange detail about Phobos itself. The moon has a very low density for a solid rock. This has led to the fascinating and well-studied theory that Phobos might not be a solid object at all. It might be partially hollow. The idea is that it could be a rubble pile moon, a collection of smaller rocks, boulders, and dust. They're all held together loosely by their own weak gravity, with large empty voids and caverns making up as much as a third of its interior. It's less a solid moon and more a flying, gravitationally bound gravel bank.
Our 11th strange fact takes us to the most volcanically active body in the solar system, Jupiter's moon, Io. We know that Io is covered in hundreds of active volcanoes that spew sulfur and sulfur dioxide. But what's truly bizarre is the height of these eruptions. Because Io has very low gravity and almost no atmosphere, the plumes from its volcanoes can shoot incredibly high. The plume from a volcano named Pele, for example, has been observed reaching an altitude of over 300 kilometers. That's like a volcano on Earth erupting and sending ash and gas all the way up to the orbit of the International Space Station. It creates a temporary, thin, sulfurous atmosphere that then freezes and snows back down onto the surface. And for fact number 12, let's visit Uranus, the tilted planet.
Its largest moon, Titania, has a canyon system that is truly colossal. One of the canyons, Messina Chasmata, is about 1,500 kilometers long. If you were to place it on Earth, it would stretch from Los Angeles to Seattle. What's remarkable is that Titania itself is a fairly small moon. The canyon is so large relative to the moon's size that it's as if our own Grand Canyon stretched all the way from New York to London. It's evidence of a massive tectonic event in the moon's past, where its icy crust was ripped apart by some immense internal force. Now for our 13th curiosity. This one takes us back to Saturn and its moon, Mimas. Mimas is a small, icy moon that is famous for one thing. It looks exactly like the Death Star from Star Wars. This is because of a single enormous impact crater on its surface named the Herschel crater. The crater is about 130 kilometers wide, almost a third of the entire moon's diameter. In the center of the crater is a prominent central peak. The impact that created this crater was so powerful that it likely came very close to shattering the entire moon to pieces. The shock waves probably propagated through the whole moon, causing the fractures we see on its opposite side. Let's leave the moons behind for a bit and talk about the other strange drifters in our solar system. For fact number 14, we return to the asteroid belt and the dwarf planet Ceres. As we've discussed, Ceres has those strange, bright salt deposits on its surface. But one of the most obscure and fascinating details is a lone conical mountain named Ahuna Mons. It's a cryovolcano, an ice volcano, and it's unlike anything else in the solar system. It's about 4 kilometers high and has bright streaks of salt running down its sides. What's so strange is that it appears to be completely isolated. Scientists are still trying to figure out what specific geological process could create a single massive ice volcano in the middle of a relatively flat, cratered plain. And now, for fact number 15, we must talk about the first confirmed visitor from another star system, the object known as Oumuamua. This Hawaiian name means scout or first distant messenger. It was detected in 2017 as it was already on its way out of our solar system. It was a truly bizarre object. It was small, dark, reddish, and highly elongated, perhaps 10 times longer than it was wide, shaped something like a cigar or a needle. But the weirdest thing about it was its motion. As it moved away from the sun, it gently accelerated, as if something were pushing it. It wasn't a comet. It had no visible tail of gas or dust. The source of this non-gravitational acceleration remains a deep mystery, leading to all sorts of speculation from outgassing of unseen volatiles to its truly exotic, alien nature. Our 16th fact takes us even further out, to the Kuiper Belt. We think of this region as being filled with icy, grayish bodies like Pluto, but many Kuiper Belt objects, or KBOs, are surprisingly and inexplicably red. Not just a little reddish, but some of the reddest objects in the entire solar system. This deep red color is thought to be caused by a surface layer of complex organic molecules called tholins. These are created when simple organic compounds, like methane and nitrogen ice, are exposed to ultraviolet radiation from the sun and cosmic rays over billions of years. This slow cooking process creates a thick, reddish, tar-like gunk that coats the surface of these distant worlds. The different shades of red we see might tell us about the original composition and history of these ancient icy bodies. For fact number 17, let's consider another resident of the Kuiper Belt, the dwarf planet Haumea. Haumea is one of the strangest objects we know of. It's not a sphere. It spins so incredibly fast,
completing a full rotation in just under 4 hours, that it has been flung outwards at its equator into the shape of a flattened, elongated American football. It is the fastest spinning large object in our solar system. Not only that, but it has its own ring system and 2 small moons. The leading theory is that Haumea's strange shape and its family of moons are all the result of a massive collision with another large object billions of years ago. The impact set it spinning rapidly and sheared off the material that would later form its moons and rings. And for fact number 18, a fact about comets. We all know they have tails, but did you know that they actually have 2 distinct tails? As a comet gets closer to the sun, its ice begins to sublimate, creating a cloud of gas and dust around its nucleus called the coma. The solar wind then pushes this material away, creating the tails. The first tail is the dust tail. It's made of tiny solid particles, and it's yellowish white because it reflects sunlight. It's broad and gently curved as the heavier dust particles lag behind in the comet's orbit. The second tail is the ion, or gas tail. It's made of charged gas particles, and it glows with a bluish light. Because these particles are so light and are strongly affected by the sun's magnetic field, this tail is always pointed directly away from the sun, regardless of which way the comet is traveling.
All right. We've explored the strange corners of our own solar system. Now it's time to broaden our view and begin our journey outwards to the stars themselves. In this next part of our quiet tour, we'll explore some of the most bizarre and obscure facts about the stars, the nebulae they live in, and the strange corpses they leave behind. Let's begin with fact number 19. We are all familiar with the basic types of stars, but there is a theoretical type of star that is so strange it sounds like something from a fantasy novel. It's called a Thorn-Zitkau object. This is a hypothetical star that is formed when a compact neutron star, the incredibly dense corpse of a supernova, spirals into and merges with a living giant star, usually a red giant or supergiant. The neutron star would sink to the core of the red giant. The resulting object would look on the outside just like a normal red supergiant, but deep in its heart, it would not be fusing hydrogen or helium. Its core would be a super-dense neutron star. The energy of this bizarre hybrid object would come from the accretion of the giant star's material onto the neutron star at its center. While we have never definitively confirmed the existence of a Thorn-Zitkau object, we have found a few candidate stars that have the strange chemical signatures that you would expect from such a bizarre merger. It's a quiet reminder that the universe is always more creative and stranger than we can imagine. Now for fact number 20. This one concerns a real star, one of the most chemically strange stars we've ever found. It's called Przybylski's star. From a distance, it looks like a fairly normal aging star, but when astronomers looked at its light spectrum, they found something deeply puzzling. The atmosphere of Przybylski's star contains almost no iron or nickel, which are common in stars of its age. Instead, it is filled with an astonishing amount of incredibly heavy exotic elements. We're talking about things like strontium, cesium, and thorium. Even more bizarrely, its atmosphere seems to contain very short-lived radioactive elements, like promethium and einsteinium, elements that should have decayed away millions of years ago. No one knows for sure how this star got such a strange chemical composition. The theories are all quite exotic. One idea is that it might be a member of that strange Thorn-Zitkau class we just talked about. Another is that it might have a dump of radioactive waste on its surface left over from a nearby undiscovered companion star that went supernova in a very peculiar way. A more fringe theory even speculates that it could be evidence of a nearby advanced civilization using the star as a dumping ground for their nuclear waste. Whatever the explanation, it's a beautiful mystery, a star whose very existence challenges our understanding of stellar evolution and chemistry. Let's move on to fact number 21. We know stars spin, but how fast can they spin before they fly apart? There are a class of stars, usually large, hot blue stars, that spin at incredible, mind-boggling speeds. One of the fastest known is a star called VFTS 102, located in a nearby galaxy. It rotates at a speed of about 600 kilometers per second at its equator. That's over 2 million kilometers per hour. It's spinning so fast that it is likely very close to its breakup velocity. The centrifugal force at its equator is so immense that it is barely able to hold itself together. This rapid spin flattens the star considerably, making it an oblate spheroid, a squashed ball. These stellar speed demons are a testament to the extreme forces at play in the cosmos. Now for fact number 22. This one takes us into the beautiful ancient star clusters known as globular clusters. These are dense balls of hundreds of thousands of very old stars. Because they're so old, you would expect all the massive, bright blue stars to have long since died out, leaving only the older, redder stars. But astronomers have found a strange population of stars in these clusters that don't seem to belong. They are called blue stragglers. These stars are hotter, bluer, and more massive than they should be. They look like they are deceptively young, even though they live in an ancient neighborhood. How is this possible? The leading theory is that blue stragglers are the result of stellar mergers or collisions. In the incredibly crowded environment of a globular cluster's core, two older, smaller stars can sometimes collide and merge into a single, more massive star. This new combined star has a fresh supply of hydrogen fuel in its core, allowing it to reignite its youth and shine brightly as a hot blue star for a while. They are like cosmic vampires, old stars that have found a way to look young again by consuming a neighbor. Let's turn our attention now from individual stars to the beautiful clouds of gas and dust they are born in and the art they create. This brings us to fact number 23 and a very strange nebula. It's called the Red Rectangle Nebula. Nebulae usually have soft, irregular, cloud-like shapes, but the red rectangle, as its name suggests, is strikingly geometric. It has a distinct X shape at its center, with a series of straight ladder-like rungs stretching outwards. It looks less like a natural cloud and more like a piece of cosmic architecture. Scientists believe the strange shape is caused by a binary star system at its center, which is spewing out gas in two opposing cones, creating the X shape, while the ladder rungs are thought to be caused by periodic eruptions from one of the stars. Our next curiosity, fact number 24, takes us back to the chaotic nurseries where stars are born. When a new star ignites, it doesn't just sit there quietly. A young, energetic star often shoots out incredibly powerful, tightly focused jets of gas from its north and south poles. For a long time, we couldn't see these jets directly, but we could see the effect they had on the surrounding space. These are known as Herbig-Haro objects. A Herbig-Haro object is not the star itself, but a small, bright patch of glowing nebulosity. They are formed when these powerful jets, traveling at hundreds of kilometers per second, slam into the surrounding clouds of interstellar gas and dust. It's like a cosmic sonic boom. The collision creates a brilliant shock wave that heats the gas and causes it to glow brightly. These objects are like celestial lighthouses, marking the hidden location of a stellar nursery. They are also fleeting. They can change their appearance noticeably in just a few years as the jets plow through the gas clouds. They are a beautiful temporary signpost of creation. Now for fact number 25. Let's look at what happens when a star like our Sun dies. It puffs off its outer layers to create a beautiful structure called a planetary nebula. One of the most famous of these is the Helix Nebula. In popular culture, it's often called the Eye of God or the Eye of Sauron because in photographs, it looks like a giant colorful eye staring back at us from space. But this incredible appearance is purely a trick of perspective. The Helix Nebula is actually shaped more like a cylinder or a garden hose. We just happen to be looking right down the barrel of the hose from our vantage point on Earth, which creates the illusion of a cosmic eye. It's a quiet reminder that our perspective on the universe is unique and sometimes a little misleading. Fact number 26 is a truly ghostly phenomenon. It's called a light echo. When a star explodes as a supernova, it sends out an incredibly brilliant flash of light that travels outwards in all directions. If there are large, sparse clouds of interstellar dust located hundreds or even thousands of light years away from the star, this flash of light will illuminate them. But because that dust is farther away, the light takes longer to reach it and then reflect back to us. So years after the original supernova has faded from view, we can suddenly see these distant dust clouds light up, one after another, as the original pulse of light washes over them. It's like a slow-motion echo of the original explosion, painting the surrounding darkness with a ghostly, reflected light. It allows astronomers to map the invisible dust clouds around the dead star. It is a beautiful and haunting reminder that the effects of a great event can continue to ripple through the cosmos long after the event itself is over. Let's now turn our attention to the strange corpses that stars leave behind. This brings us to fact number 27. For a long time, we thought that planets could only exist around stable, living stars. But in 1992, the very first confirmed exoplanets, planets outside our solar system, were discovered in the strangest place imaginable. They were found orbiting a pulsar. A pulsar is a type of rapidly spinning neutron star, the super-dense corpse of a massive star that went supernova. It's a place of intense radiation and extreme gravity. No one expected to find planets there, but astronomers detected a slight wobble in the otherwise perfectly regular radio pulses coming from a pulsar named PSR B1257+12. They realized that this wobble was being caused by the gravitational tug of at least two small rocky planets orbiting the dead star. No one is sure how they got there. They might be the tough rocky cores of gas giants that somehow survived the supernova explosion, or they might have formed out of the debris disk that was left behind after the explosion. Whatever their origin, they are zombie worlds, orbiting a stellar ghost. And for fact number 28, another strange feature of these spinning stellar corpses. Pulsars are the most accurate timekeepers in the entire universe. Their rotation is incredibly stable, but sometimes, very rarely, a pulsar will suddenly and inexplicably speed up its rotation by a tiny fraction. This is called a glitch. For a brief moment, the pulsar's clockwork rhythm is broken. Scientists believe these glitches are caused by something happening inside the neutron star. The interior is thought to be a superfluid, a state of matter that flows with zero friction. It's possible that as the star's solid crust slowly spins down, the faster spinning superfluid core can suddenly transfer some of its angular momentum to the crust, causing it to speed up in a sudden jolt. It's a glimpse into the bizarre physics happening inside these incredible objects. Now for fact number 29. We know that stars like our Sun will end their lives as hot, dense white dwarfs, which then slowly cool down over eons. But what happens after that? What is the final, ultimate end state? If you wait long enough, trillions upon trillions of years, far longer than the current age of the universe, that white dwarf will eventually radiate away all its remaining heat and will become a cold, dark, inert ball of crystallized carbon and oxygen. This theoretical object is called a black dwarf. It's the true corpse of a star. The universe is not yet old enough for any black dwarfs to have formed, so their existence is purely theoretical, but they are the quiet, cold fate that awaits the vast majority of stars in the cosmos. And for our 30th fact, fact number 30, there is a class of neutron stars that are completely silent. We detect most pulsars because their magnetic poles sweep a beam of radio waves past the Earth, like a lighthouse. But what if a neutron star's beams just don't happen to point at us? Or what if its magnetic field is too weak to produce strong beams at all? These silent neutron stars would be almost impossible to detect. They would just be dark, city-sized cinders drifting through the galaxy. We have found a few of them by detecting the faint heat they still give off, but there are likely millions of them out there, a hidden population of stellar ghosts that we will never see. All right, we've explored the curiosities of our solar system and the strange lives of stars. Now it's time to zoom out even further to the grand scale of galaxies and the universe itself. Let's drift into the quiet, ghostly structures that define the cosmos. We begin with fact number 31. We know that most galaxies are either beautiful spirals, like our own, or large football-shaped ellipticals. But sometimes we find galaxies that defy all classification. One of the most mysterious of these is Hoag's object. Discovered in 1950, it is a stunning and almost perfectly symmetrical ring galaxy. It consists of a bright, old, yellowish core, completely surrounded by a perfect, detached ring of young, hot blue stars. And in the vast gap between the core and the ring, there appears to be almost nothing. No one is sure how such a strange object formed. Ring galaxies are usually thought to be the result of a smaller galaxy plunging through the center of a larger disk galaxy, creating a ripple effect. But there is no sign of the bullet galaxy that would have caused this. Another theory is that it was once a barred spiral galaxy, whose central bar structure became unstable and broke down. Whatever its origin, Hoag's object is a beautiful, quiet puzzle, a piece of cosmic jewelry with an unknown story. Now for fact number 32. We know that most large galaxies, including our own, have a single supermassive black hole at their center. But what happens when two galaxies collide and merge? Their central black holes will eventually find each other and begin a slow gravitational dance, orbiting each other for millions of years before finally merging. Astronomers have found several galaxies that appear to have two supermassive black holes at their core, the telltale sign of a recent galactic merger. These binary black holes are one of the most powerful sources of gravitational waves in the universe. Our next curiosity, fact number 33, takes us back to the early universe. Using data from a project where citizen scientists helped to classify galaxies, astronomers discovered a strange and unique class of objects they nicknamed green pea galaxies. These are small, compact, and intensely green-colored galaxies. The green color comes from the brilliant light of ionized oxygen, which indicates that these galaxies are undergoing an incredibly rapid and violent burst of star formation. They are some of the most efficient star-forming galaxies in the entire universe. They are thought to be relics from the early cosmos, small galaxies from billions of years ago that we are just now seeing, giving us a glimpse into the chaotic and energetic youth of the universe. From the intensely bright, let's turn to the impossibly faint for fact number 34. This is the strange case of ultra-diffuse galaxies, or UDGs. These are cosmic ghosts. A UDG can be as large as our own Milky Way galaxy, spanning tens of thousands of light years, but it contains only about 1% as many stars. The stars are so incredibly spread out that the galaxy is almost completely transparent. It would be almost impossible to see with the naked eye, even if you were right next to it. What holds these fragile, sparse collections of stars together? The answer seems to be dark matter. UDGs appear to be almost entirely made of dark matter, with just a light sprinkling of stars embedded within them. They are a quiet puzzle that challenges our theories of how galaxies form and hold themselves together. And that brings us from the mostly empty to the truly empty. For fact number 35, we must visit one of the most unsettling places in the entire cosmos, the Boötes void. In the 1980s, astronomers were making the first large-scale maps of the universe, plotting the positions of thousands of galaxies. They discovered that galaxies are not spread out randomly. They are arranged in a vast, web-like structure with long filaments and dense clusters of galaxies surrounding huge, almost empty regions. These empty regions are called voids, and the largest of these that we know of is the Boötes void, sometimes called the Great Nothing. It is a colossal, roughly spherical region of space, about 330 million light-years in diameter, and it is almost completely empty. Based on the average density of the universe, a region this large should contain thousands of galaxies, but we have only found about 60 in the entire Boötes void. If our own Milky Way galaxy were at the center of this void, we would not have even known that other galaxies existed until the 1960s, when our telescopes became powerful enough to see across that immense, empty expanse. The night sky would be a place of profound and absolute blackness beyond our own local stars. It's a quiet, humbling reminder that the universe is not uniform, but has a grand, lumpy structure of great walls and even greater emptiness. From the largest empty space, we now turn to one of the largest structures ever discovered for fact number 36. This is the Hercules Corona Borealis Great Wall. As astronomers mapped the sky, they noticed that galaxies formed these long, thread-like structures called filaments. In 2013, while mapping the locations of gamma-ray bursts, astronomers found a huge concentration of them in a particular region of the sky. This suggested the presence of a massive galactic supercluster, a great wall of galaxies. And it is immense. It is estimated to be about 10 billion light-years across. This is so large that it actually challenges our modern understanding of cosmology, as the universe might not be old enough for a structure this large to have formed through gravity alone. It is a quiet, colossal mystery written across our sky. Now for fact number 37, a mystery written into the very first light of the universe. This is a strange anomaly in the cosmic microwave background radiation, the afterglow of the Big Bang. In theory, the temperature fluctuations in this background radiation should be completely random, the same in all directions. But when our satellites, like WMAP and Planck, mapped it out in incredible detail, they found a strange, unexplained pattern. There seems to be an alignment of the largest scale fluctuations along a particular axis in space, an axis that is strangely aligned with the plane of our own solar system. This has been nicknamed the axis of evil, not because it's sinister, but because it's a thorn in the side of cosmologists. It seems to suggest that our little solar system has a special privileged alignment with the entire universe, which shouldn't be possible. Most scientists believe it's likely just a statistical fluke, a random pattern in the noise that we are overinterpreting. But it remains a quiet, persistent, and deeply puzzling cosmic anomaly. Let's now turn from the grand and cosmic to a single fleeting whisper in the static. This is fact number 38, the story of the WOW signal. In 1977, an astronomer named Jerry Ehman was using the Big Ear radio telescope to scan the skies as part of the SETI project, the search for extraterrestrial intelligence. He was looking at data printouts from the telescope, long sheets of paper filled with numbers representing radio signal strength. In the midst of all the random background noise, he saw something astonishing. For a period of 72 seconds, the telescope had detected a strong, narrowband radio signal coming from the direction of the constellation Sagittarius. It was exactly the kind of artificial, structured signal that SETI researchers were hoping to find. It was so strong and so clear that Ehman famously circled the data on the printout and wrote the word "WOW" next to it. The WOW signal remains one of the greatest mysteries in the history of astronomy. The signal never repeated. Astronomers have pointed their telescopes back to that same patch of sky hundreds of times over the past decades and have never heard anything like it again. It was a single, powerful, and apparently intelligent-looking shout in the cosmic darkness, and then silence. We will likely never know for sure what it was. It could have been a signal from an Earth-based source that was reflected back off a piece of space debris. It could have been a strange, unknown natural phenomenon. Or it could have been exactly what it looked like, a brief, fleeting whisper from someone else, far away. It is a quiet, tantalizing puzzle. Our next curiosity, fact number 39, is another mystery from a single star. It concerns a star known as KIC 8462852, more famously known as Tabby's star, after the astronomer Tabitha Boyajian, who led the team that studied it. This is a fairly normal-looking star, slightly larger and hotter than our Sun, but the Kepler Space Telescope, which was monitoring its brightness, detected something very, very strange. The star was experiencing deep, brief, and completely irregular dips in its brightness. A transiting planet, for example, might dim a star's light by about 1%, but Tabby's star was dimming by as much as 22%. And the dimming wasn't periodic like a planet's orbit. It was completely unpredictable. Something huge, or a swarm of many things, was periodically blocking the starlight. The natural explanations, like a swarm of comets or a dust cloud, don't seem to fully fit the data. This led to a brief flurry of excited and very speculative media attention around the idea that perhaps we were seeing an alien megastructure, a giant piece of technology being built around the star. While that is extremely unlikely, the true cause of the strange dimming of Tabby's star remains a quiet and fascinating scientific mystery. Let's now turn from the distant cosmos back to our own solar system for a moment, for fact number 40. We often think of volcanoes as erupting hot, molten rock. But on the icy moons of the outer solar system, a different kind of volcano exists. This is cryovolcanism, or ice volcanism. On worlds like Neptune's moon Triton, or Saturn's moon Enceladus, internal heat can melt subsurface ice, creating pockets of liquid water, or a slushy mixture of water, ammonia, and other volatiles. This subsurface liquid can then be forced up through cracks in the icy crust and erupt onto the surface. But instead of lava, these volcanoes spew out water, ammonia, and methane, which then instantly freeze into a shower of ice crystals in the cold vacuum. The plumes from Enceladus are a perfect example of this. It's a quiet, cold, and beautiful geological process, a reminder that volcanism in the universe can take on many strange and wonderful forms. Our 41st fact, fact number 41, is a strange detail about Saturn's rings. We know they are made of countless particles of almost pure water ice, but what's truly bizarre is the range of sizes of these particles. They are not all the same. The ring particles range in size from tiny dust grains, smaller than a particle of smoke, all the way up to boulders as large as a house or a bus. The entire system is a complex, sorted collection of these ice chunks, all orbiting Saturn in a disk of unimaginable thinness. And how this sorting of particles occurs, and why the composition is so purely water ice, is still a subject of intense scientific study. It's a quiet, beautiful, and deeply complex puzzle right in our own cosmic backyard. All right, we've journeyed through the strange features of our solar system, the peculiar lives of stars, and the grand, ghostly structures of the cosmos. For this next part of our tour, let's come back home, in a way. Let's explore some of the more obscure, quiet, and wonderfully human footnotes from our own brief history of space exploration. We begin with fact number 42. This one is a story of incredible, almost impossible bad luck. It's the story of Anne Hodges, who is, to this day, the only confirmed, undisputed person in history to have been struck by a meteorite. On November 30th, 1954, Anne was napping on her couch in her home in Sylacauga, Alabama. A meteorite, about the size of a softball, tore through the roof of her house, bounced off her large console radio, and struck her on the hip. It left a massive dark bruise, but miraculously, she was not seriously injured. The event caused a local sensation, and the meteorite itself, a fragment of a larger object that had broken up in the atmosphere, became the subject of a legal dispute. It's a quiet, bizarre reminder that the universe can sometimes reach down and touch us in the most direct and unexpected ways. Now for fact number 43. This is a story of something lost and then found. In 1961, Gus Grissom piloted the second American spaceflight, a suborbital mission called Liberty Bell 7. The flight itself was successful, but after splashing down in the Atlantic Ocean, things went wrong. The capsule's explosive hatch blew prematurely.
Water began to flood into the tiny capsule, and it quickly sank to the bottom of the ocean, nearly taking Grissom with it. He was rescued, but his spacecraft was lost, lying on the seafloor nearly 5 kilometers down.
For nearly 4 decades, the Liberty Bell 7 capsule was a lost piece of space history. But in 1999, a privately funded expedition led by underwater explorer Kurt Newport finally located and recovered the capsule from the dark, cold depths of the ocean. It was a remarkable feat of deep-sea exploration. The capsule was carefully restored and is now on display in a museum, a recovered relic from the very dawn of the space age. Let's move from the bottom of the ocean to the far side of the moon for fact number 44. In May of 1969, just 2 months before the historic Apollo 11 landing, the crew of Apollo 10 performed a full dress rehearsal. They flew to the moon, and 2 of the astronauts, Thomas Stafford and Eugene Cernan, descended in their lunar module, nicknamed Snoopy, to within just 9 miles of the lunar surface before returning to dock with John Young in the command module, Charlie Brown. During their time orbiting the far side of the moon, they were completely out of radio contact with Earth. And during this period of radio silence, the astronauts heard something very strange. It was a faint, ethereal whooshing sound, almost like music, coming through their headsets. They were baffled by it, and their confused and amazed conversation was captured on the mission's voice recorders. They debated whether they should even report it to mission control, worried that people might think they were going crazy. The cause of the space music is thought to have been simple radio interference between the VHF radios of the lunar module and the command module. But for a few strange moments, the crew of Apollo 10 were the first humans to hear a mysterious, otherworldly sound in the quietest place imaginable.
Now for fact number 45, a story that is both deeply scientific and profoundly poetic. It's the story of Eugene Shoemaker. Shoemaker was a brilliant planetary geologist who helped to pioneer the field. He trained the Apollo astronauts in geology and dreamed of one day walking on the moon himself. Unfortunately, a medical condition prevented him from ever becoming an astronaut. He continued his incredible career, co-discovering the famous comet Shoemaker-Levy 9 that slammed into Jupiter. After he passed away in 1997, a former colleague came up with a special way to honor his lifelong dream. A small portion of his ashes was placed aboard the Lunar Prospector spacecraft, which was launched in 1998. After completing its mission of mapping the moon from orbit, the spacecraft was deliberately crashed into a permanently shadowed crater near the lunar South Pole. Eugene Shoemaker remains, to this day, the only person whose ashes have been laid to rest on another celestial body. His final resting place is the world he dreamed of walking on his entire life. From a final resting place, let's turn to a first impression. This is fact number 46, the true smell of space. Space itself, being a near-perfect vacuum, has no smell. But when astronauts return to their spacecraft after a spacewalk and they remove their helmets, they consistently report a very distinct and peculiar odor clinging to their suits and equipment. It is not the smell of nothing, it is a sharp, metallic, and slightly acrid smell. Different astronauts have described it in different ways. Some have compared it to the smell of seared steak, hot metal, or welding fumes. Others have said it smells like the scent left in the air after a lightning strike. This smell is thought to be caused by the interaction of atomic oxygen, which clings to the spacesuit fabric in the vacuum, with the moisture and air inside the cabin. It's the smell of high-energy vibrations and newly formed ozone. A strange, sharp scent from the thin boundary between our world and the void. Our 47th fact, fact number 47, is a fun and strange piece of physics that happens in a vacuum. It's called the Leidenfrost effect. You might have seen this effect in your own kitchen. If you sprinkle a few drops of water onto a very hot frying pan, they don't just boil away instantly, they skitter and dance across the surface, lasting for a surprisingly long time. This is because the bottom layer of the water droplet instantly vaporizes, creating a cushion of steam that insulates the rest of the droplet from the hot surface. Now, what happens in the near-perfect vacuum of space? Water at room temperature will boil instantly. But if you have a droplet of water and a very hot surface, the same effect can happen. The rapid boiling of the water can create a temporary vapor cushion that allows the droplet to survive and skitter around for a moment before it completely dissipates. It's a small, curious piece of physics that shows how even the simplest things like a drop of water behave in strange and unexpected ways when you take them away from the familiar environment of Earth. For fact number 48, let's revisit the very first meals in space. We know that John Glenn was the first American to eat in space, squeezing applesauce from a tube. But who was the very first human to do so? That honor belongs to the Soviet cosmonaut German Titov, who orbited the Earth in August of 1961, a few months before Glenn. On his Vostok 2 mission, Titov ate a 3-course meal from tubes consisting of a vegetable soup, a meat puree, and some blackcurrant juice. He actually became the first person to experience space sickness and reportedly felt quite unwell after his meal. It was the first, and perhaps not the last, case of cosmic indigestion.
Now for fact number 49. The International Space Station is often described as being silent, but that's not quite true. While there is no sound outside in the vacuum, the inside of the station is a place of constant noise. It is filled with the unceasing, gentle hum of machinery. This is the sound of the station's life support systems, the fans that circulate the air, the pumps that move coolant, the scrubbers that remove carbon dioxide, and the computers that control everything. This constant background hum is about as loud as a vacuum cleaner running in the next room. It is the sound of the machine that is keeping the astronauts alive. New arrivals on the station often find it difficult to sleep with the constant noise, so they wear earplugs, but veteran astronauts say that they quickly get used to it. The hum becomes a comforting, familiar sound, the white noise of their orbital home. They say that if the hum were to ever stop, that sudden, perfect silence would be the most terrifying sound in the world, because it would mean something had gone terribly wrong. Our 50th fact, fact number 50, is a fun little biological quirk of living in space. Astronauts get taller. Here on Earth, the force of gravity is constantly compressing our spines. The cartilage discs between our vertebrae are always slightly squished. When an astronaut goes into space, this gravitational compression is removed. Their spine is free to relax and elongate. As a result, an astronaut can temporarily grow by as much as 2 inches in height while they are in orbit. Of course, this extra height is temporary. When they return to Earth, gravity quickly gets to work and they shrink back down to their normal height within a few days. It's a strange and temporary benefit of a weightless life. And so we've taken a long and meandering journey through some of the universe's strangest little secrets. We started with our own planetary neighbors, discovering their hidden personalities, a shrinking Mercury, a Venus with metallic snow, and an Earth with a second secret moon. We toured the bizarre worlds of the outer solar system, from the two-toned face of Iapetus
to the cantaloupe skin of Triton. We visited worlds shaped like ravioli and worlds that might be hollow. We then journeyed outwards to the stars, finding bizarre stellar hybrids with neutron stars in their cores and stars with impossibly strange chemical compositions. We visited a cosmic art gallery filled with geometric nebulae, ghostly light echoes, and the beautiful debris of dying suns. We found zombie planets orbiting dead stars and listened to the strange, sudden glitches in their clockwork pulses. We zoomed out even further to the grand scale of galaxies and found more strangeness. We saw perfect ring galaxies with unknown origins, ghost galaxies made almost entirely of dark matter, and a great empty void in the universe larger than our minds can comfortably hold. We listened for whispers in the cosmic static, and we found the tantalizing and unexplained wow signal, a single, fleeting shout in the great silence. And finally we came back home, to the human side of the story, and found our own collection of strange footnotes. The only person ever hit by a meteorite, a lost spaceship recovered from the bottom of the sea, the ghostly music heard by the Apollo 10 crew, and the quiet, constant hum of life aboard our home in orbit.
We've covered 50 strange and wonderful facts tonight, but we've only just scratched the surface. The universe is not just a place of grand, sweeping laws and predictable orbits. It is also a place of infinite, quirky, and often inexplicable detail. It is a cabinet of curiosities that is always larger than we think. For every mystery we solve, we seem to uncover a dozen new ones that are even more puzzling. And that, I think, is a wonderfully calming thought. It means that the journey of discovery will never be over. There will always be new things to wonder about, new quiet puzzles to contemplate. The obscurity of these facts is not a property of the universe itself, but simply a measure of our own limited knowledge. We are still at the very beginning of our journey of understanding. The universe is under no obligation to make sense to us or to be simple. It is complex, it is strange, and it is beautiful in its weirdness. And appreciating that weirdness, I think, is a form of humility. It's an acknowledgement that we are a small part of a very large and very old story, filled with chapters we have not yet read.
But our journey isn't quite over. We have many more pages to turn in our quiet book of cosmic curiosities. Let's drift back to our own solar system and begin our next set of explorations. We start with fact number 51. Let's go back to Saturn's beautiful moon Enceladus. We know it has geysers of water erupting from its south pole. But what's truly obscure is that these geysers are so powerful and so consistent that they have created one of Saturn's rings all by themselves. The faint, diffuse E ring of Saturn is composed almost entirely of the tiny ice crystals that have been blasted out of Enceladus over millions of years. This tiny moon, no bigger than the state of Arizona, is actively building and sustaining a planetary ring system. It's a beautiful example of a small moon having a huge impact on its local environment. And now for fact number 52. Staying with Saturn, let's talk about the strange spokes in its rings. For decades, astronomers have observed strange, dark, radial features that appear and disappear in Saturn's B ring, the densest and brightest part of the rings. These spokes can be thousands of kilometers long and can form and dissipate in a matter of hours. They defy normal orbital mechanics. They seem to rotate around the planet as if they were a solid part of a wheel. For a long time, their origin was a complete mystery. The leading theory now is that they are caused by electrostatic forces. Tiny, charged dust particles are being levitated by Saturn's magnetic field just above the main ring plane, creating these temporary shadowy features. They are, in essence, giant clouds of electrostatically levitating ring dust.
Let's head to Jupiter for fact number 53. Jupiter has the most powerful auroras in the solar system, but they are created in a very different way than Earth's. While our auroras are powered by the solar wind, Jupiter's are mostly powered by its own incredible rotation. Jupiter spins so fast and has such a powerful magnetic field that it creates a huge electrical dynamo. This dynamo sweeps up particles that have been erupted from its volcanic moon Io and accelerates them, slamming them into its own poles to create a permanent, brilliant aurora that is hundreds of times more powerful than our own. It generates its own light show. And for fact number 54, a strange detail about Jupiter's most famous feature, the Great Red Spot. We know it's a giant storm, but recent data has shown that this storm is surprisingly deep. It's not just a surface feature, it extends at least 300 kilometers down into the planet's atmosphere. What's even stranger is that the storm appears to be shrinking. Over the last century, it has shrunk from being wide enough to fit 3 Earths across it to now being only just wider than 1 Earth. Scientists don't know if this is a temporary change or if the Great Red Spot is slowly, over centuries, going to fade away entirely. Our next fact, fact number 55, takes us back to the asteroid belt. The Dawn spacecraft, which visited the dwarf planet Ceres, also visited the second largest asteroid, Vesta, and it found something incredible. Vesta has one of the largest impact craters in the solar system, named Rhea Silvia. The crater is so enormous that the central peak in the middle of the crater is over 20 kilometers high, making it one of the tallest mountains in the entire solar system, rivaling Olympus Mons on Mars. This impact was so colossal that it blasted off a huge chunk of Vesta's crust, and scientists have identified a whole family of smaller asteroids orbiting the Sun that are all fragments from this single, ancient, violent event.
Now for fact number 56, a strange truth about our own planet. The Earth is not a quiet place in space. It actually hums. Scientists have detected a constant low-frequency hum or vibration that our planet is always emitting. It's too low-pitched for human ears to hear, but it can be detected by sensitive seismometers. For a long time, the source was a mystery, with theories ranging from atmospheric disturbances to ocean wave interactions. The most recent research suggests that the hum is generated by the slow, constant churning of the Earth's molten outer core, a deep planetary vibration from the very heart of our world. And fact number 57 is another earthly curiosity. Every single day, our planet is showered with about 100 tons of dust and sand-sized particles from space. This material is the leftover debris from comets and asteroids. It's a constant, gentle rain of extraterrestrial material. Most of it burns up harmlessly in our atmosphere, but it's a quiet reminder that our planet is not an isolated system. We are constantly interacting with the wider environment of our solar system. Let's move to our neighbor Venus for fact number 58. Venus is a planet of extremes, but one of its strangest features is its lightning. Probes have detected powerful lightning storms in its thick sulfuric acid clouds, but Venusian lightning is different from Earth's. It's thought to be non-cold lightning,
created not from water ice crystals like on Earth, but from the static electricity generated by the sulfuric acid droplets rubbing against each other. It's a form of acid cloud lightning in a hellish sky. For fact number 59, we go to one of the coldest places in the solar system, the permanently shadowed craters on our own moon. We know they contain water ice, but what's truly obscure is that these are some of the coldest spots ever measured in our entire solar system, even colder than the surface of Pluto. Because they never see sunlight and are protected from even reflected heat, the temperature at the bottom of these craters can dip below minus 240 degrees Celsius. They are cold traps that have been preserving ancient ice for billions of years.
And for our 60th fact, fact number 60, a final strange detail about Mercury. We know it's a shrinking planet, but the way it shrinks is uneven. The contraction of its iron core has created a global network of those cliff-like sparks. But these sparks are not randomly distributed. They seem to be concentrated in certain areas, leading to a complex pattern of tectonic activity that is unlike the plate tectonics of Earth or the simple cracking of the moon. Understanding this unique, wrinkling pattern is a key to unlocking the thermal history of the planet and the secrets of its giant, mysterious core. Now, let's once again drift away from our own solar system and back out into the deeper stellar neighborhood to continue our collection of curiosities. This brings us back to our second category. Let's begin with fact number 61. We talked about how strange Przybylski's star is, with its bizarre heavy elements. But another strange aspect is its slow rotation. It takes about 188 years for the star to complete a single rotation. This is incredibly slow for a star of its type. This has led to the theory that its strange chemistry might be related to its slow spin. Perhaps the lack of mixing in its atmosphere allows incredibly heavy elements, which would normally sink out of sight, to linger in its upper layers where we can see them with our telescopes. And for fact number 62, a fact about a star that no longer exists. In 2002, a seemingly ordinary star in a distant galaxy known as V838 Monocerotis suddenly and dramatically brightened, becoming 600,000 times more luminous than our Sun. But it wasn't a supernova. It didn't explode. It just swelled up massively and then faded away. This is not a type of stellar outburst we had ever seen before. The light echo it produced was one of the most beautiful ever photographed by Hubble. But the cause of the outburst remains a mystery. It might have been the merger of two smaller stars or a star swallowing one of its own giant planets. It's a quiet reminder that our catalog of how stars can behave is still incomplete.
Now for fact number 63. Let's talk about a star that fails to explode. We think of supernovae as the inevitable dramatic end for any massive star. But some theories suggest that the most massive stars in the universe, those more than 40 or 50 times the mass of our Sun, might die with a whimper instead of a bang. When their core collapses, it forms a black hole so massive and with such intense gravity that the outgoing shock wave from the collapse simply isn't powerful enough to escape. The shock wave stalls and is swallowed by the newborn black hole. The entire star then just falls into the black hole, disappearing from the universe with no visible explosion at all. This is called a failed supernova. Astronomers are actively searching for this phenomenon by looking for stars in other galaxies that suddenly vanish without a trace. It's a quiet, eerie end for the universe's biggest titans. Our 64th curiosity, fact number 64, is another strange type of stellar explosion. It's a class of supernova known as a calcium-rich supernova.
These are dimmer and evolve much faster than a typical supernova, and most strangely, they produce an unusually large amount of the element calcium in their explosion. They are often found far from any young massive stars in the lonely space between galaxies, which suggests they have a different origin. The leading theory is that they might be caused by the explosion of a small white dwarf star that has been stealing helium from a companion star, leading to a unique kind of thermonuclear event. They are a quiet and mysterious class of explosion that helps to see the universe with the very calcium that makes up our bones. And for fact number 65, we return to the bizarre world of pulsars. We know of one system called PSR 0737-3039, which is a double pulsar. It's a binary system where not one, but both of the objects are spinning neutron stars, both detectable as pulsars. This is an incredibly rare and scientifically valuable discovery. It is a perfect natural laboratory for testing Einstein's theory of general relativity in an environment of extreme gravity. By precisely timing the arrival of the pulses from both stars, astronomers can measure tiny changes in their orbits, and they have confirmed that the two stars are slowly spiraling closer together, losing energy in the form of gravitational waves at exactly the rate predicted by Einstein's equations.
Now, let's leave the world of stars and zoom out once more into the grand realm of galaxies to continue our exploration of the strange structures that populate the cosmos. This brings us back to our third major section. We'll begin with fact number 66. We've talked about the strange ring galaxy known as Hoag's object. But what makes it even more mysterious is that when astronomers look at it with powerful telescopes, in the vast empty space between the golden core and the blue outer ring, they can see another much fainter ring galaxy in the background, billions of light years away. It is an almost perfect cosmic coincidence, seeing one of the rarest types of galaxies in the universe, and then seeing another one directly through its center. It's a beautiful, quiet alignment that feels almost intentional, a little wink from the universe. And for fact number 67, another galactic oddity. We are used to thinking of galaxies as being either blue, if they are young and forming stars, or red, if they are old and filled with dying stars. But astronomers have found a population of galaxies that are in a strange middle ground. These are the Green Valley galaxies. They are galaxies where star formation has only recently shut down. They have used up most of their gas, so they are no longer forming bright blue stars, but their existing stars have not yet had time to age and turn red. So they are left in this transitional greenish-yellow color phase. They are a snapshot of a galaxy in its quiet, awkward teenage years, moving from a vibrant youth to a sedate old age. Now, let's get even stranger with fact number 68. We know supermassive black holes live at the center of galaxies. But in 2017, astronomers found a galaxy that seems to have a wandering supermassive black hole.
The galaxy, known as GSN 069, is a normal spiral galaxy, but the supermassive black hole at its center isn't staying put. Every 9 hours, it lets out a bright flash of X-rays. This regular, repeating flare is thought to be caused by a smaller star in a very tight eccentric orbit around the black hole. Each time the star makes its closest approach, the black hole strips a little bit of material from it, which then falls into the accretion disk and creates the X-ray flash. This is strange enough, but some evidence suggests the black hole itself is not at the gravitational center of the galaxy. It seems to be oscillating or sloshing around, perhaps because of a past galactic merger that disturbed its stable position. It's a quiet giant that is not at rest. For fact number 69, we revisit the strange green pea galaxies. What makes them so special is not just their intense star formation, but their ability to leak radiation. Most galaxies have enough neutral hydrogen gas to absorb the high-energy ultraviolet radiation produced by their young stars. But these green pea galaxies are so small and are forming stars so furiously that they seem to have blown away their own gas, allowing this ionizing radiation to escape into intergalactic space. This is incredibly important because it's thought that this kind of leakage from small, early galaxies is what caused the epoch of reionization, a key event in the early universe where the dark, neutral hydrogen that filled the cosmos was zapped and made transparent, allowing light to travel freely for the first time. These little green galaxies are a living window into the universe's dramatic dawn. And for fact number 70, we look at the cosmic web. The universe's large-scale structure is a network of dense filaments of galaxies surrounding vast empty voids. But in 2014, astronomers discovered that the supermassive black holes at the centers of quasars in a very large region of space all seem to be aligned. Their spin axes were all pointing in the same direction despite being billions of light years apart. This is not something our current cosmological models predict. Gravity should be random on these scales. It's a quiet, large-scale anomaly that suggests there might be some unknown physics, some primordial alignment from the very beginning of the universe that we do not yet understand.
Now, let's talk more about the largest and emptiest places in the universe. We mentioned the Boötes void for fact number 71. Let's just quietly contemplate its scale. It is 330 million light years in diameter. If you were to travel at the speed of light, it would take you 330 million years just to cross it. It is so large that it represents about 0.25% of the entire observable universe. And yet it is almost completely empty. The handful of galaxies that have been found inside it seem to be arranged in a strange tube-like structure. The existence of such a colossal void is a challenge for our models of cosmic evolution. It suggests that the lumpiness of the universe, the structure of its great walls and voids, might be even more extreme than we thought. It is the quietest, loneliest place we know of. And for fact number 72, a strange feature of our own cosmic neighborhood. When we look out at the cosmic microwave background radiation, the afterglow of the Big Bang, we see that it is incredibly uniform in temperature. But there is one unusually large and unusually cold spot in the sky. This CMB cold spot is a region of space that is slightly cooler than its surroundings. It's a statistical anomaly that is very unlikely to be just a random fluctuation. One of the more speculative theories is that this cold spot could be the imprint of another universe bumping into our own, a piece of evidence for the multiverse. A more mainstream idea is that it's caused by a supervoid, an even larger empty region than the Boötes void that lies between us and the background radiation. The light from the CMB would lose a little energy as it crossed this void, making it appear colder to us. It's another great, quiet cosmic mystery.
Now for fact number 73. Let's talk about gravitational lensing. We know that massive objects can bend the path of light. Sometimes this can create multiple images of a single distant object. In 2015, astronomers using the Hubble Space Telescope observed a supernova in a distant galaxy that had been perfectly lensed by a massive galaxy cluster in front of it. The gravity of the cluster was so strong it bent the light from the supernova along several different paths. Because these paths were different lengths, the images of the supernova arrived at our telescope at different times.
astronomers saw the supernova explode, and then they saw it explode again in a different position a few weeks later, and then again and again in 4 different images. They were even able to predict with incredible accuracy when and where the final image of the supernova would appear a year later, as its light took the longest path around the lensing cluster. It was a beautiful and profound confirmation of Einstein's theories. Our next curiosity, fact number 74, brings us back to the famous wow signal. While we don't know what caused it, we do know some very strange things about it. The signal was observed for 72 seconds, which is exactly the length of time the Big Ear telescope's design would take to observe a fixed point in the sky as the Earth rotated. This suggests the signal was coming from a specific fixed celestial source. It was also a very clean, narrow-band signal, occupying a very narrow range of frequencies, and most intriguingly, the frequency it was at, 1420 megahertz, is the natural emission frequency of hydrogen gas, the most common element in the universe. This has led some to speculate that this would be the logical calling card frequency that an intelligent civilization would choose to broadcast on. A quiet hello sent on the universe's own natural channel.
Let's now begin our final descent down the iceberg of curiosities. We are leaving the grand cosmos behind and returning to our own little corner of it to focus on the strange, quiet footnotes of our own human journey into space. We begin with fact number 75. We often worry about the danger of something from space hitting the Earth, but what about it hitting a person? It has happened, officially, exactly once. The story is that of Ann Hodges of Sylacauga, Alabama. On a November afternoon in 1954, she was napping on her couch when a grapefruit-sized meteorite tore through the roof of her house, bounced off her large console radio, and struck her on her hip and hand. It left a massive dark bruise, but thankfully she wasn't seriously injured. She remains the only confirmed, undisputed person in history to have been directly struck by an object from outer space. It's a quiet reminder that sometimes the universe can get very, very personal. Now for fact number 76, a strange and almost forgotten piece of space history. In 1961, astronaut Gus Grissom piloted the second American suborbital spaceflight in a Mercury capsule he had named Liberty Bell 7. The flight was successful, but after splashing down in the Atlantic, the capsule's explosive side hatch blew open prematurely. Water began to flood into the tiny capsule. Grissom managed to get out just in time, but his spacecraft, filled with water, sank to the bottom of the ocean, nearly 5 kilometers down. It was a lost relic of the dawn of the space age. For nearly 4 decades it lay there in the dark. But in 1999, a privately funded expedition finally located it and, in a remarkable feat of deep-sea engineering, recovered it. It's now restored and on display, a quiet piece of history pulled back from the abyss.
Our next fact, fact number 77, takes us to the far side of the moon. In May of 1969, just 2 months before the historic first landing, the crew of Apollo 10 flew their lunar module, Snoopy, down to within 9 miles of the lunar surface in a full dress rehearsal. As they orbited the far side of the moon, they were completely cut off from radio contact with Earth. It is one of the quietest places a human can be. And during this period of radio silence, the astronauts heard something completely unexpected through their headsets. It was a faint, ethereal, whooshing sound,
like strange music. The mission transcripts capture their confused and amazed reactions. They whisper to each other, "Did you hear that? That sounds like, outer space type music." They were so baffled and a little unnerved by it that they debated whether they should even report it to mission control, worried that people might think the experience was getting to them. The space music is now believed to have been caused by simple radio interference between the VHF radios of the lunar module and the command module orbiting nearby. But for a few strange, quiet moments, the crew of Apollo 10 were the first humans to hear an unexplainable and otherworldly sound in the deepest silence imaginable. For fact number 78, a story that is both deeply scientific and profoundly poetic. It's the story of Eugene Shoemaker. Shoemaker was a brilliant planetary geologist who helped to pioneer the field and trained the Apollo astronauts how to identify lunar rocks. His lifelong dream was to one day walk on the moon himself, but a medical condition kept him from becoming an astronaut. He continued his incredible career, most famously co-discovering the comet Shoemaker-Levy 9. After he passed away in 1997, NASA decided to grant him his final wish. A small portion of his ashes was placed aboard the Lunar Prospector spacecraft. In 1999, after its mission was complete, the spacecraft was deliberately crashed into a crater near the moon's south pole. Eugene Shoemaker remains the only person whose final resting place is on another world.
Now for fact number 79. What does space actually smell like? The vacuum itself has no smell, of course, but astronauts returning to their spacecraft after a spacewalk consistently report a very distinct and peculiar odor clinging to their suits, helmets, and tools. It's a smell they can only experience once they are back inside the airlock and can remove their helmets. They don't all describe it in exactly the same way, but the descriptions are consistently strange and strong. Many have compared it to the smell of seared steak, hot metal, or the fumes from welding. Others have said it smells like burnt almonds or spent gunpowder. It's a sharp, metallic, acrid scent. Scientists believe this smell of space is caused by single atoms of oxygen, known as atomic oxygen, which are common in low Earth orbit. These highly reactive atoms cling to the fabric of the spacesuits. When they are brought inside and mix with the cabin air, they react with other molecules to create these strange burnt odors. It's the scent of the raw edge of space itself. For fact number 80, a small but fascinating fact about water in space. We know liquids behave strangely in 0G, but the Leidenfrost effect, which we talked about before, becomes even more pronounced in a vacuum. If an astronaut were to release a droplet of water onto a hot surface inside a depressurized chamber, the outer layer of the water would boil instantly. But this boiling creates a temporary cushion of water vapor that insulates the rest of the droplet, allowing it to skitter and dance across the surface for a surprisingly long time before it completely vaporizes. It's a beautiful and slightly counterintuitive piece of physics that demonstrates how the simple things we take for granted on Earth behave in wonderfully complex ways in space.
Let's revisit the history of space food for fact number 81. We know that the first meal eaten in space by an American was John Glenn's tube of applesauce. But what was the first food eaten on the surface of the moon? After landing the Eagle, and before their historic moonwalk, Neil Armstrong and Buzz Aldrin had a meal. The official NASA menu lists their first meal as bacon squares, peaches, and sugar cookie cubes. But Aldrin also famously performed a private communion ceremony, consuming a small wafer of bread and a sip of wine. So, depending on your definition, the first food and drink consumed on another world were the elements of a Christian sacrament. And for fact number 82, we'll talk about the sounds of the International Space Station. From the outside, it is completely silent, but from the inside, it is a place of constant
unceasing noise. The ISS is filled with the continuous, gentle hum and whir of machinery. This is the sound of the station's life support systems, the fans circulating the air, the pumps moving coolant to regulate temperature, the scrubbers removing carbon dioxide from the atmosphere, and the myriad of computers that control every aspect of the station. This constant background hum is about as loud as a residential air conditioner. For new arrivals, it can actually be difficult to sleep with the constant noise, and many wear earplugs. But for veteran astronauts who spend months on board, the hum becomes a familiar and even comforting sound. It is the sound of the machine that is keeping them alive. They say that if the hum were to ever stop, that sudden, perfect silence would be the most terrifying sound in the world, because it would mean something had gone terribly and catastrophically wrong.
Our 83rd fact, fact number 83, is a fun little biological quirk of living in space. One we've touched on before, but is worth its own quiet moment. Astronauts get taller. Here on Earth, the force of gravity is constantly compressing our spines. The soft, cartilage discs that sit between each of our vertebrae are always slightly squished down by our own weight. When an astronaut goes into the weightless environment of space, this gravitational compression is removed. Their spine is free to relax and elongate, to stretch out to its natural length. As a result, an astronaut can temporarily grow in height, sometimes by as much as 2 inches over the course of a long mission. Of course, this extra height is not permanent. When they return to the crushing gravity of Earth, their spine slowly recompresses and they shrink back down to their normal height within a few days or weeks. Let's now consider fact number 84. This is a strange one about lightning on Jupiter. We know Jupiter has massive lightning storms, far more powerful than any on Earth. But for a long time, we couldn't figure out where it was coming from. The radio signals from the lightning didn't match what we'd expect from clouds at the altitudes where water exists. Recent data from the Juno spacecraft has solved the mystery. It turns out that Jupiter's lightning is often upside down. It originates in clouds that contain a slushy mixture of water and ammonia ice high up in the planet's atmosphere. This creates a kind of shallow lightning that is completely different from the deep water cloud-based lightning we have on our planet. For fact number 85, a quiet detail about our own planet's dance with the sun. We are used to thinking of the planets orbiting the sun, but that's not quite accurate. The planets and the sun actually orbit a common center of mass called the barycenter. For smaller planets, this point is well within the sun itself. But Jupiter is so massive that the barycenter of the Jupiter-Sun system is actually located just outside the surface of the sun. So technically, the sun makes a small, wobbly orbit around this invisible point in space, tugged there by the immense gravity of its largest planet.
We continue our exploration of the strange ways the human body reacts to space with fact number 86. Astronauts often run a slight, persistent fever. It's not caused by illness, but by the weightless environment itself. On Earth, our bodies have very efficient ways of shedding excess heat, especially through convection, where warmer air rises off our skin. In the zero-G environment of a space station, where there is no up for warm air to rise to, this process doesn't work. The air around an astronaut's body can form a stagnant, warm bubble. As a result, their core body temperature consistently runs about 1 degree Celsius higher than normal. It's a low-grade, constant space fever, another small way the body struggles to adapt. Now for a truly strange and specific medical issue for fact number 87. It's the problem of astronauts losing their fingernails. This condition, called onatolysis, happens surprisingly often, especially to astronauts who perform a lot of spacewalks. The reason is the design of the spacesuit gloves. The gloves are pressurized and stiff, and maneuvering tools and handholds for hours on end puts a tremendous amount of pressure and restriction on the fingertips. This can cut off blood flow and cause a delamination of the nail from the nail bed. It's a quiet, painful, and deeply weird consequence of working in a pressurized suit. Our 88th fact, fact number 88, is about the other life forms on the space station. The ISS is not a sterile environment. It is teeming with a unique microbial ecosystem of bacteria and fungi that the astronauts bring with them from Earth. These microbes form biofilms on the walls and equipment. Scientists constantly monitor this microbial environment, both out of concern for astronaut health and out of scientific curiosity. They've found that some bacteria can become more resilient or even more virulent in space, while others struggle to survive. The ISS is, in a way, a tiny self-contained experiment in microbial evolution.
Fact number 89 takes us into the realm of human conflict. In 2019, the first ever allegation of a crime being committed in space was reported. It involved an astronaut on the ISS allegedly accessing the bank account of her estranged spouse back on Earth without permission. While the case was complex and was ultimately dismissed, it raised a host of new and fascinating legal questions. Which country's laws apply in orbit? How would you conduct a criminal investigation? It's a quiet reminder that wherever humans go, we take our complex lives and our complex problems with us. For fact number 90, let's return to the sounds of the space station. We know it has a constant background hum, but it also creaks and groans. As the ISS orbits the Earth once every 90 minutes, it passes from direct, intense sunlight into the cold darkness of Earth's shadow. This causes rapid and extreme temperature swings on the station's exterior. The metal trusses and modules expand in the heat and contract in the cold. This constant thermal stress causes the entire station to produce a symphony of quiet, groaning, and pinging sounds as the metal flexes. For the astronauts inside, it's the familiar sound of their house settling on a cosmic scale. This brings us to the end of our exploration of the human element. For our final set of facts, let's look at some of the most profound and quiet philosophical puzzles and grand ideas about the universe as a whole. If you assume the universe is infinite, infinitely old, and filled with a uniform distribution of stars, then no matter which direction you look, your line of sight should eventually end on the surface of a star. In such a universe, the entire night sky should be as bright as the surface of the sun, but it's not. It's dark. This is the paradox. The resolution to this puzzle is one of the key pieces of evidence for the Big Bang Theory. The universe is not infinitely old. It began about 13.8 billion years ago. This means the light from stars that are farther away than 13.8 billion light years simply hasn't had time to reach us yet. Furthermore, the universe is expanding. This expansion stretches the light from distant galaxies, shifting it to redder, lower energy wavelengths, making them fainter. The darkness of the night sky is a quiet, beautiful testament to the fact that our universe has a finite age and is in a state of constant expansion. Now for a much lighter curiosity. Fact number 92. What is the average color of the universe? In 2002, a team of astronomers took the light from over 200,000 galaxies and averaged it all together to find out. The answer? A slightly beigeish off-white color. They decided to hold a vote to give it a more poetic name. The winning name was Cosmic Latte. So after all the brilliant blues of young stars, the fiery reds of nebulae, and the deep black of the void, the universe, on average, is the color of a quiet cup of coffee with a little too much cream. Fact number 93 is a quiet mystery from our own space program. It's called the Pioneer Anomaly. The Pioneer 10 and 11 spacecraft were launched in the 1970s and are now heading out into interstellar space. For decades, as scientists tracked their trajectory, they noticed a tiny, unexplained anomaly. Both spacecraft were slowing down, just a little bit more than our models of gravity predicted.
It was as if some tiny unknown force was gently pulling them back towards the sun. The Pioneer Anomaly was a deep mystery for a long time, leading to all sorts of speculative theories about new physics. However, after years of painstaking analysis, scientists now believe they have solved it. The most likely cause is a very subtle effect called thermal recoil. The spacecraft's small nuclear power source generates heat, and this heat radiates away from the spacecraft unevenly, mostly off the back of the main antenna dish. This tiny outward radiation of heat photons creates an equally tiny, almost immeasurable amount of thrust back towards the sun, which perfectly accounts for the mysterious deceleration. It's a beautiful example of a quiet, complex problem being solved by careful, patient science. Now for fact number 94. A look to the future of space travel. We know that rockets are incredibly inefficient. So how might we travel to other stars one day? One of the most promising ideas is the light sail. A light sail is a vast, ultra-thin reflective sheet, like a giant piece of tinfoil in space. Light itself exerts a tiny amount of pressure when it hits a surface. Over a huge area, this gentle pressure from sunlight or from a powerful ground-based laser could slowly but constantly accelerate the sail to incredible speeds. The Breakthrough Starshot project is a real-life initiative that is trying to develop this technology to send tiny nanocraft with sails to the nearest star system, Alpha Centauri, potentially accelerating them to 20% the speed of light and making the journey in just 20 years. Let's return to the moon for fact number 95. Why are some countries and companies so interested in going back? One reason is the potential for lunar resource mining, specifically for a substance called helium-3. Helium-3 is a light, stable isotope of helium that is incredibly rare on Earth, but is thought to be relatively abundant on the Moon, where it has been deposited by the solar wind for billions of years. The reason it's so valuable is that it's the perfect potential fuel for clean and efficient nuclear fusion reactors of the future. It's a quiet, long-term economic incentive for our return to the Moon.
For fact number 96, we revisit the mystery of the Great Attractor. We know that our galaxy and all our neighbors are being pulled towards a massive, unseen concentration of mass. But the strange thing is that even when we account for the pull of the Great Attractor, there seems to be another, even larger scale motion. Our entire local supercluster, a vast structure containing thousands of galaxies, appears to be moving as a whole. This large-scale uniform motion is called dark flow. Its existence is still debated, but if it's real, it suggests that our observable universe might be influenced by the gravity of massive structures that are outside our visible horizon, structures that we can never directly see. It's a quiet hint
that our little cosmic neighborhood is just a small part of a much, much larger story. Let's now consider fact number 97, a potential, if mundane, solution to the famous wow signal. While the alien intelligence theory is the most exciting, other, more natural explanations have been proposed. One of the leading hypotheses is that the signal could have been generated by a passing comet. Comets are surrounded by a huge, tenuous cloud of hydrogen gas. It's possible that the Big Ear telescope happened to be looking at a comet whose hydrogen cloud was either stimulated by some background radio source or was emitting naturally, producing a strong, temporary narrowband signal that looked artificial. It's a less romantic explanation, but a plausible one. Our 98th fact, fact number 98, is about how we get our spacecraft to the outer solar system efficiently. It's the beautiful art of the gravity assist or slingshot maneuver. Instead of pointing a spacecraft directly at its target and firing the engines the whole way, mission planners use the gravity of planets to get a boost. By flying close to a massive planet like Jupiter, a spacecraft can steal a tiny bit of the planet's immense orbital energy. The planet's gravity pulls the spacecraft in, swings it around, and then flings it out at a much higher speed. The Voyager probes used a series of these gravity assists from Jupiter, Saturn, Uranus, and Neptune to conduct their grand tour of the outer solar system, a journey that would have been impossible with the rocket technology of the time alone. It's a quiet, clever cosmic billiards game. And that brings us to fact number 99, a story from one of those Voyager probes. In 1990, the Voyager 1 spacecraft, having long since passed its primary targets, was far out on the edge of the solar system. The astronomer Carl Sagan, who was a key member of the Voyager imaging team, had a beautiful, poignant idea. He requested that NASA turn Voyager's camera around one last time to take a final picture of its home. From a distance of about 6 billion kilometers, Earth appeared as a single tiny point of light, a pixel less than 1/10 of a size of a single pixel on the camera's sensor. It was captured in a scattered ray of sunlight, making it look like a small pale blue dot suspended in the vastness. This image, the pale blue dot, is one of the most famous and profound photographs ever taken. It shows our world as a fragile, lonely, and beautiful mote of dust, the only home we've ever known, seen from the perspective of the great dark cosmic ocean. It's a quiet, powerful image that beautifully captures our place in the universe. And finally, we reach our 100th and final curiosity, fact number 100. Aboard both the Voyager 1 and Voyager 2 spacecraft is a special message, a greeting to any cosmic wanderer who might one day find them. This is the Golden Record. It is a gold-plated copper phonograph record containing sounds and images selected to portray the diversity of life and culture on Earth. It contains greetings in 55 different languages, starting with Akkadian spoken 6,000 years ago and ending with modern Chinese dialects. It contains sounds from our planet, like the sound of wind and rain, the calls of whales and birds, and the sound of a human heartbeat and laughter. It contains 90 minutes of music from all over the world, from Bach and Beethoven to Chuck Berry and traditional folk music. And it contains 115 images showing our solar system, our anatomy, and scenes of human life. It is a message in a bottle thrown into the cosmic ocean. It is a quiet, hopeful testament to who we were and a greeting to whoever or whatever might be out there. And so, our long and meandering journey through this cabinet of cosmic curiosities comes to a quiet end. We have turned 100 pages in our strange, dusty book of space facts. We started in our own solar system, discovering the secret lives of our planetary neighbors, a shrinking Mercury, a Venus with metallic snow, and Mars with a hollow moon. We toured the bizarre satellite systems of the gas giants, finding moons shaped like ravioli, moons that look like the Death Star, and moons that erupt with geysers of ice. We then drifted outwards into the stellar neighborhood and found a zoo of peculiar stars, stars that have swallowed other stars, stars with impossible chemistry, and old stars pretending to be young. We visited a cosmic art gallery filled with geometric nebulae and ghostly light echoes, and we explored the bizarre physics of the tiny, dense corpses that stars leave behind. We zoomed out even further, to the grandest scales imaginable, and found galaxies shaped like perfect rings, galaxies with two hearts, and ghost galaxies made of almost nothing at all. We contemplated the great nothing of the Botez void, and the mysterious, unexplained whispers in the cosmic static, like the wow signal. And finally, we came back home, to the small, strange, and often poignant footnotes of our own human journey into space. We heard the story of the only person ever hit by a meteorite, the ghostly music heard on the far side of the moon, and the final, lonely photograph of our own pale blue dot. What a strange and wonderful universe it is. It is not just a place of majestic, sweeping laws and predictable clockwork orbits. It is also a place of infinite, QWERTY, and often beautifully inexplicable detail.
And that, I think, is a wonderfully calming thought to end on. It means that the journey of discovery, the quiet process of looking at the sky and finding something new, will never, ever be over. There will always be another strange star, another peculiar galaxy, another quiet anomaly in the data waiting to be found. There will always be another page to turn in that dusty, forgotten book. The obscurity of these facts is not a property of the universe itself, but simply a measure of our own, still very limited knowledge. We are, in the grand scheme of things, just beginning our journey of understanding. We are children, just starting to notice all the strange and wonderful details in the vast, ancient house we live in. So as you drift off to sleep tonight, let these small, strange facts be like a gentle, meandering stream for your mind to follow. Let them be a quiet reminder that the cosmos is not just majestic, but also deeply, wonderfully strange. And in that strangeness, there is a kind of profound and endless beauty. The universe is under no obligation to be simple for us, and in its complexity, in its quiet weirdness, we can find a deep sense of peace and wonder. The more we learn, the more we realize just how much more there is to discover. And that is a beautiful thought to fall asleep to. Sweet dreams.